In this part of the tutorial, we will create the event sealed class, ViewModel, and Presenter for the ActiveGame feature. Before we do that, let us look at a few design decisions involved in this architecture. The purpose of our presentation logic class, which I call Logic for short, is exactly as the name implies. It handles the work of coordinating the container, ViewModel, and backend repositories. If notified of a nonstop event, it will also cancel all coroutines. It does not possess any Android platform code, which makes it loosely coupled and very easy to test. I might also consider reusing it for a desktop version of this app, but we'll see. The purpose of the ViewModel is also to do exactly what the name implies. It is a virtual representation of the user interface which the view observes. In simpler terms, it is a model of the view. It exposes function types, which is a very simple and easy stand-in for the observer pattern in situations where we don't require multiple observers. Each time our logic class updates the ViewModel will automatically publish the new data to the view. Another design decision with this ViewModel is that it does not extend Jetpack ViewModel. There are several reasons for this decision, some of them simple and some of them quite technical. The simple reason is that using Jetpack ViewModel creates tight coupling with the Android platform, and it has its own set of boilerplate code and dependencies, which I'm not a huge fan of. In short, it doesn't solve more problems than it creates in this particular application, and I wanted to practice creating view models which might be usable for Kotlin Desktop or Kotlin JS. The technical reason why is that in this application we simply don't need to persist the data across activity instances or process death in order to have a good user experience. Instead, we just make a fairly cheap call to the Android file system and reload the data from there if such events occur. Now, before you apply that reasoning in every situation, understand that reloading data from a file system works fine in this application, but should not be considered a suitable replacement for on-save instance state in every application you write. If you like view models and save state handle, go right ahead and use it. We also employ the strategy pattern to clean up the interface which our logic class exposes to the container and the view. Each subclass of the sealed class represents an action that can occur in the view or container. Rather than having a function for every UI event, we have one function that accepts a single object that can represent multiple different paths of execution. That's the strategy pattern. Right-click on the UI package and go to New Package called ActiveGame. Right-click on this new package, go to New Kotlin File or Class, and we're going to create an interface, and it's going to be called ActiveGame Container. This word container is a technical term. The way I'm using it here is to kind of signify something which contains a large portion of an application or an entire application. In my opinion, a container doesn't usually deal much with the business kind of logic of the application. It basically just wires things together and builds things and kind of serves as an entry point. In the next part of this tutorial, I'll explain what we'll actually be using as a container, but by using an interface here, I'm basically stating quite explicitly that I might change my mind about what we use as a container. Anyways, it only contains two abstract functions. Right-click on the ActiveGame package again, and we're going to create a sealed class this time. And it's going to be called ActiveGame Event. So as I explained in the above comment, the ActiveGame Event sealed class represents every kind of user interaction of a given feature, in this case the ActiveGame feature. This is a very common pattern that I use, and we'll see how it works with our BaseLogic abstract class which we created in the common package. Okay, we are now going to create our view model. Firstly, let's create a small little class here which will be like a virtual representation of a single tile in a Sudoku puzzle. So obviously x and y represent the x and y coordinates of the particular Sudoku tile. Value will represent what we talk about in graph data structures as the color. Again, it's literally just a number. I don't know why we need to call it a color. Now, has focus indicates that the user has clicked on a particular tile, after which they can click on one of the input buttons to change that particular number. And finally, a read-only tile you can think of as a tile which is like a given clue in the puzzle, so therefore the user is not allowed to actually change any read-only tiles. So before we start writing this view model, I just wanted to mention a couple of things here. As discussed in the introduction for this particular section, I didn't actually want to use any of the Jetpack libraries to achieve a publisher-subscriber relationship between the view model and the view. Now, it turns out that that publisher-subscriber relationship or pattern is actually quite easy to implement, but in this case I actually found it simpler to just use Kotlin's function types to achieve what I would call a poor person's publisher-subscriber pattern or observer pattern. So this really means something simple in practice, although it might look kind of complicated for those who aren't really familiar with working with function types. Our view model will possess these nullable function type references. As we'll see in a moment, what we can do is each time we update the view model from the presentation logic class, we can then update the view by extension by invoking these function types from within the view model. Now, the reason why we're using nullables here is from within the view model, I can never be 100% certain if there is actually anything listening. But with that being said, I feel like if I played around with this particular class for a couple of hours, I could probably streamline a little bit and maybe make some of these internal variables private or something like that. So really what I'm saying here is feel free to take this general idea of having a view model which isn't tightly coupled to Android Jetpack, but also feel free to experiment with it and see if you can optimize it. So with that out of the way, let's create some function types. So all of these function types will be prefixed with sub to ensure good legibility. Active game screen state is actually something we will create in the next part of this tutorial, so just go ahead and leave it glowing red here. Okay, let me just briefly explain these different function types. So the board state is basically a virtual representation of the Sudoku board, obviously. The content state basically just means three different states. So either we're loading the data, the user has a currently active game that they're solving, or the user has completed a particular game. We will use this to animate between different states in the user interface. Now, timer state has to do with the Countup Timer, which basically records how long it takes for the user to complete a given Sudoku game. So just to hopefully clear up any confusion here, timer state will be the actual long value in milliseconds representing the time, and then subtimer state is the way that we actually update the user interface after we update the new timer state. Let's finish off the rest of these variables. These are quite obviously default values. Next, we'll write a function to initialize this view model. Okay, so let's just pause for a moment. What we're doing here is we're taking the state of the data as it existed in storage, we're giving it to the view model, and then what we're doing is we're building the view model's own virtual representation of that state. Now, the view model's internal representation will have things like has focus, which are concerns specifically of the user interface and not necessarily something that I would include in the original domain model. Also, in case you're wondering, the key value is basically created from hashing the X value and the Y value. This is something that we covered very early on in this tutorial in case you've jumped ahead. Again, active game screen state is something that we will create in the compose part of the tutorial. Here we're binding that data to the view model, and then we will invoke our function types to update the view, assuming it's listening. And that's it for our init function. Now we just have a few more functions which will be called by our presenter to do various things with the state of the view model. So here we're just updating an individual tile. So what we're doing here is when the user hits a particular tile, that's going to send a message into the presenter, which will have a particular X and Y coordinate. And then the presenter will call this particular function. And so what it'll do is it'll look for the tile which the user clicked on based on that X and Y value and set that one to has focus equals true. And then for every other tile, we want to set it to false. Otherwise, we could have a situation where the user has selected multiple different tiles, which is not something our application is supposed to be allowed to do. And this would be the situation where our backend has determined that the current puzzle is complete. Right-click on the active game package, and let's create a new Kotlin class, which is going to be called Active Game Logic. Okay, so before we proceed, this is definitely one of those situations where I strongly suggest having the complete source code open on the side while you follow along here. Obviously, I'm going to do my best not to make any mistakes, but it's possible that I will make a mistake. Active game logic represents the presentation logic of this particular feature of the application. As we'll see, it coordinates between the container, the view model, and then by extension the view, as well as the back end of the application. Let's start with the constructor. Okay, so just a bit of review before we move on. For the time being, the container will actually be an activity, but there's a possibility in the future I might move to using fragments as containers instead. At this point I don't really want to, but we'll just see if that makes sense in the future. But this is the entire reason why I have included an interface here, so that I can change what's behind the interface very easily. The view model is pretty clear, we just wrote it. Game repo is where we store the game data, so that includes the game settings as well as the current progress of the user's game. Stats repo is where we store the records for the shortest times to completion of each different difficulty and size of puzzle. And if you're wondering what the dispatcher is, go back and watch the common package. When we created that, we created this dispatcher provider, and I basically explain what the purpose of it is there. BaseLogic is also something that we created in the common package, and we'll see the function that we inherit from that class in a moment. Okay, let's talk for a moment about coroutines. So one way to think about scopes, whether we're talking about coroutine scope or dagger or whatever, is to really just consider that it's about a life cycle. Now you're probably wondering, why are we not making something like a view model or a fragment or an activity our lifecycle class? Well, in case you haven't noticed by now, I don't like any kind of tight coupling to the Android platform if I can avoid it. There's a number of other reasons, but one of the main ones is that because this class contains all of the presentation logic, in a sense it's the head decision maker for this feature of the application, then in my opinion it makes sense to make it responsible for cancellation of any coroutines which happen to be currently running. As far as this onEvent function which we inherit from BaseLogic, well basically this is an implementation of the strategy pattern. I won't give you a long and technical explanation here, it's actually a very simple pattern. But basically it provides sort of like a singular entry point into this particular class. So instead of having like a single function for every event, we have one function which takes in an argument, our active game event, which is capable of representing all the different events. And I just find that really cleans up the interfaces between different classes. Interfaces is used in the general sense in that statement. Okay, first let's implement our coroutine context. Remember, job tracker exists in BaseLogic, but we also need to initialize it. Okay, now before we proceed, there's something really important we need to implement, which is a coroutine timer. As I mentioned before, the active game screen does have a Countup Timer. Now, some of you are probably going to be wondering, why didn't I use the Java timer class or the Android's Countup Timer or whatever it's called? Basically, I did try using those things and they presented different application breaking problems, and it turned out to be easiest just to create this kind of coroutine timer. Okay, so this requires a little bit of explanation, obviously. So we'll notice two different keywords here which might be unfamiliar to some of you. We have the inline and cross-inline keywords. So whenever you see the inline keyword, the easiest way to understand that is to understand that it just means copy-paste. And if you want to know what that means in code, then I suggest you decompile some of your Kotlin code which uses the inline modifier, and you'll see how the inline function is actually copy and pasted into the call site. Now we have something else going on here, which is a cross-inline function type. So before I explain what the cross-inline action is, let's talk about what this function actually does. So here we have a pretty standard spin lock while true, so it's a loop that's going to just endlessly execute. It's going to invoke that function type, and then it's going to delay for 1,000 milliseconds. Now there's a couple different things going on here. Number one, you have to understand that we will be delaying this coroutine, but it's not actually going to block the thread that it's on, which is of course a big win. Now the other thing that's going on here is action is going to be a lambda expression that we will pass into this particular function. Really the only thing cross-inline does is it basically makes it so that in the lambda function, which we will pass into this function here, we're not allowed to write a return statement in that function. So in the most general sense here, what we're doing is we're taking a preventative step to avoid a situation where we might accidentally return from within the lambda that we pass in here, causing unexpected behavior. Now you're probably wondering, since we have this endless loop going on, how do we actually stop this particular coroutine? Well, what we're going to do is we're going to create a job. Let's just do that now. And what we'll do soon is we will actually assign this job variable to our start coroutine timer, and that will allow us to cancel it. Let's just write another quick extension function to do with this timer business, and then I'll explain what it does. In experimenting with the user interface, how to make the timer the least janky or most accurate that it could be, it turned out that subtracting 1 from the value each time we write it to the backend created a more consistent timer. But one particular edge case is if the value equals 0, then obviously we don't want to subtract 1 from it, otherwise the timer will say -1 at first, and that just doesn't look very good. Okay, so with all that done, we can get to implementing the rest of the presentation logic. Okay, so when the user hits an input button, we kind of have two different situations that could occur. In one situation, the user has already selected a tile, which would become the focus tile, or it might be that they just hit an input button without actually focusing a tile, in which case we don't really want to do anything. Okay, so if you're wondering about the details of game repo, you can go back to the part of the tutorial where we actually build it. Basically, we're going to be creating a lambda to represent the success case, and then another lambda to represent like an error or exception case. To make that a little bit more legible, I'll just add in a comment here. Okay, so if you're again wondering how we actually cancel the timer, this is exactly how we do it. We cancel the job object. Now we'll write this other function in a moment. Basically, if it's a new record, then we want to render the user interface slightly differently than if it wasn't a record. But before we do that, let's finish off the error case. So in order to actually know if it's a record, we actually need to pass the value back into the stats repo just to check on that. So I'm going to be honest, the error handling in this application is not the best, neither is it really the worst. Show error will, for the time being, just actually show a toast message explaining that some error occurred. Okay, just a quick fix, this is actually supposed to be elapsed time, not timer state. Next we have on new game clicked. You'll notice a recurring theme here, which is that anytime we want to perform concurrent operations, so anytime we're working with the backend, we're going to wrap that into a launch coroutine. There's a lot of different ways to work with coroutines. This is just one of the most simple, straightforward ways to do it, in my opinion. Okay, so what we're doing here is first we're asking the ViewModel, has the user completed the current game? If they haven't, we actually want to store the progress the user has made in their current game when they hit on new game clicked, because maybe they hit it by accident or they want to be able to go back and finish the game or some reason like that. Let's write the update with time function. Again, we have success and error cases. Hopefully that's pretty clear at this point. Next, we'll implement that function. Next, we'll write the cancel stuff function. So basically the cancel stuff function essentially cancels every coroutine. Next we'll write onStart. I forgot to mention earlier, the reason why we had an underscore in one of the functions for isComplete, it's just kind of a convention for a lambda argument or parameter which doesn't actually end up getting used. In this case, we are going to use it. Okay, so obviously this is where we start the coroutine timer, and we only want to do that when onStart is called. Now again, I feel like I could have handled this a little bit better. It kind of goes against my rules to consider standard flow of the application as an exception. But basically what we're going to do here is, in the event that we ask the storage for a current game and it doesn't actually retrieve anything, generally speaking, this situation is going to occur when the user has run the application for the first time, and hence there wouldn't actually be any data stored. So in that particular case, we would want to do this. Now, we could also end up here because of some kind of legitimate exception, but in that particular case, I still think navigating to the new game feature is still actually a good way to handle that. Good, but maybe not the best. Next we have onStop. Okay, so onStop is actually tied to the lifecycle of the Android activity or fragment that it's bound to. So when this function is called, that basically means that we want to save the user's current progress and then kind of shut everything down. Finally, we have on tile focus, so this would be when a user actually selects a particular Sudoku tile. Now, this function is incredibly complicated, so brace yourself. Okay, I lied. That's actually everything we need to do.